In this video, we will continue with section 7.2, which is rules of differentiation involving two or more functions of the same variable. That means we have some function f of x and we have some function g of x. The first rule is the sum difference rule. This means if we want the derivative with regards to x of the function f of x plus g of x, this would be equal to the derivative with regards to f of x plus the derivative with regards to g of x. This is simply f prime x plus g prime x. This is also true for a difference. Second, we have the product rule. This is where we want the derivative with regards to x of f of x times g of x. This is equal to f of x times the derivative of g of x plus g of x times the derivative of f of x, which is equal to f of x g prime x plus g of x f prime x. So how do we prove this product rule? We have in the previous videos discussed how to prove these function rules. We need an original point and a new point. If you can't remember what these are, refer back to the previous video. So if we have the derivative with regards to x of f of x g of x, and we want this at x equal to n, this will be equal to the limit as x approaches n of the product of f of x g of x minus f of n g of n over x minus n. In order to get our slopes, we want f of x minus f of n over x minus n, and we want g of x minus g of n over x minus n. To get this, we add f of x g of n minus f of x g of n to this limit here. That means our new limit as x approaches n of f of x g of x minus f of n g of n plus f of x g n minus f of x g n divided by x minus n. This gives us, by rearranging the terms, the limit as x approaches n of f of x g of x minus f of x g n plus f of x g n minus f of n g n. All of this over x minus n. So what do we have? F of x g of x, f minus fn gn minus fn gn plus fxgn plus fxgn minus fxgn minus fxgn. So all our terms are still in this function. Now we can factorize above. We have f of x times g of x minus g of n minus g of n, or plus g of n, times f of x minus f of n over x minus n. We have the limit of two sum functions, which is the limit as x approaches n of f of x g x minus g n over x minus n, plus the limit of g of n times f of x minus f n over x minus n. So now we have gx minus gn, which is equal to g prime x, and we have fx minus fn over x minus n, which is f prime x. That means our limit as x approaches n is f of x of g prime x plus the limit as x approaches n of gn f prime x. If we take the limit, it becomes f of n g of n plus g prime n gn f prime n, and this is equal to this function. So if we do an example, we have f of x equal to 6x squared plus x, and g of x is equal to 12x plus 6, and we want the derivative with regards to x of f of x g of x. So we want f of x g prime of x plus f prime x g x. F of x is equal to 6x squared plus x. G prime is 12 plus f prime of x is equal to 12x plus 1, and g of x is 12x plus 6. And then if we simplify these functions, we get 72x squared plus 12x plus 144x plus 72x plus 12x plus 6, which is equal to 72x squared plus 240x plus 6. We can also do this for the third rule, which is the division rule. This is where we want the derivative with regards to x of f of x divided by g of x. This is equal to f prime x g x minus f x g prime x over g squared x of x. Let's prove this function. So it's the derivative with regards to x of f of x divided by g of x at x equal to n. That means we want the limit as x approaches n of f of x divided by g of x minus f of n divided by g of n, everything over x minus n. So to simplify this, we take the limit as x approaches n of f of x, g of x, minus f of n, g of n, times 1 over x minus n. So we can simplify this even further by placing these two factors on a common denominator, which would be x, gx, gn. To get gx, gn, we need to multiply fx by gn, and we need to multiply fn by gx. Everything multiplied by x minus n, 1 over x minus n. Remember, we want fx minus fn divided by x minus n. So in this case, we add fn gn. So we add fn gn and we subtract fn gn to this first part. So what are we left with? This means we want the limit. The limit as x approaches n of fx gn minus fn gx plus fn gn minus fn gn, all of this over gx gn times 1 over x minus n. Okay. We take then the limit as x approaches n. We take this denominator, 1 over gx minus g times gn. Just write that neatly. 1 over gx gn times, again, we want fx minus fn. So in this case, we have gn times fx minus fn. So where do we get these terms? We have gn and gn, fx and fx. So these would be these two terms. Minus f of n is a common denominator in these two, times g of x minus g of n, which is these two terms. Note the sign changes. All of this over x minus n. And that is equal to the limit as x approaches n of 1 over gx gn fx minus fn over x minus n is f prime x minus gx minus gn is minus f of n g prime of x. Just write that neatly. G prime x. Then we take the limit, which is gn times g of n f prime n minus fn g prime n. That is equal to g n f prime n minus fn g prime n over gn times gn is g squared of n. And this equation is the same as this equation. An example: if we have f of x is equal to ax squared plus b, g of x is equal to cx, f prime of x is then equal to 2ax, g prime of x is equal to c. So the derivative of f of x divided by g of x with regards to x will be equal to g of x times f prime x minus f of x g prime x over g squared of x. G of x is equal to cx, f prime of x is equal to 2ax, minus f of x is ax squared plus b, g prime of x is equal to c. G of x is equal to cx squared. This gives us 2acx squared minus ax squared times c plus bc. Everything over c squared x squared. 2acx squared minus cax squared is acx squared plus bc over c squared x squared. We have c in both terms, so ax squared plus b over c squared x squared, which is equal to ax squared plus b over cx squared.